So I'll introduce myself here. I'm a research software engineer working on the Secure Water Future project. Well, I'm Nick Santos first. That helps. Research software engineer working on the Secure Water Future project at UC Merced. I develop models, software, databases, and decision support applications to help analyze and understand California agriculture as well as environmental impacts and indicators. You'd think I could do that without reading it, but I didn't. Okay, yeah, and so I'm presenting on high volume OpenET data access using open source Python clients we developed for the OpenET API and for Google Earth Engine. And it starts with the question, what would you do if you needed to access dozens of months of ET data across large swaths of the Western US, as we did for Emily's alfalfa study? There are a few different ways you could do it. If you have the expertise on your team, you can run your analysis directly in Earth Engine. That's a great solution, but also requires training people up if you don't already have that expertise. But what if you want to work with the data outside of Earth Engine? You're left with exports, which work, but don't have wonderful tooling around them. And then you're left with OpenET API, which is wonderful, but also doesn't necessarily have a class of clients available for it and has potential quota implications if you're doing lots and lots of data. So how do you actually go about it? What's the tooling that you use for that? And before I dive into that, I'm curious, how many of you have worked with OpenET data outside of the Online Explorer or outside of Earth Engine before? How many of you tried that? Okay, cool. So my crowd, here we go. So this is gonna be a little bit of a pitch for you all. So we built two different clients that enable easier bulk access to OpenET data across large spatial or temporal extents, or small ones. You could do it with whatever you like. We first, in 2021, built a Python package we call OpenET client that simplified access directly to OpenET's V1 API at the time. And then later on, we built EDL, which is a generic package for bulk access and exporting of data directly from Earth Engine. So it takes you straight from, I have an image in Earth Engine, it can be computed or an asset, and I want it on my machine and let my computation continue once I have that image on my machine. And it does everything in between. And I'm gonna start with OpenET client, even though I'm gonna say up front, it's broken. And that's where the pitch comes in, because we developed it for the V1 API. I haven't had the personal staff time to bring it up to the V2 API. But I'm gonna tell you about it because the structure of it I think is useful, and I'm hoping we can build a community around these clients and make them truly an open source contribution that helps support the OpenET ecosystem. The key features, use Python functions. So if you have staff who know Python but don't know what a REST API is, they don't need to. They can read Python documentation and go for it. It also handled, in the V1 API, automatic matching of your polygons to OpenET field IDs. So you start with polygons and you get your ET data back to polygons, and it handles the whole thing in between. And it also handled automatic weighting and downloading of raster exports. So those were features we needed. We segmented it a lot like the OpenET API itself with geodatabase and raster sections. But I think there's a lot of room for improvement if we were to bring this up to the V2 API. So just a few examples, you don't need to read this code, you don't need to understand this code. This isn't to try to train you up. We have documentation for that. This is just to show a bit of the simple side of it. So we start at the top. There's that big block of green text here. Those are the arguments. Those are basically constructed the same way you would construct a request to the OpenET API. Those are the same arguments you would provide if you were manually sending a request. And then you initialize your client, and then you say, I want a raster with these arguments, and resume my code when it's done. That's one line right there. You have your arguments, you say, give me this raster, and your code resumes when the raster is on your machine. So you don't need expertise in the multiple API endpoints, waiting for rasters, looking to see if they're done. You just get the image when it's done. So that was our initial use case for this. The next few, I might have hidden one of them because you don't need to see it all, but there are multiple ways of intervening. You could also export many rasters and say, okay, let me know when they're all done. Or you can do manual control. So there's this wait for rasters. You export multiple ones. You could do it in a loop. And then you say, wait for all of them and let me know when they're ready. And similarly, I think the example I cut is just that you can do fully manual control and actually pull for the rasters yourself. So you can integrate that with your other functionality where you say you're doing other analysis in the meantime, and then you say, okay, if this raster's ready, go get it. So you could do everything in between. We also built some code for the geodatabase API. This looks a little more complicated, maybe because it is, but what I really wanted is we had new staff coming online. They were new to Python, they were new to OpenET, they were new to APIs, but they knew spatial data, and they had polygons, and they wanted ET data for those polygons over many months. And so we have functions here where you just say get ET for features, you pass it in this case it's a GeoPandas data frame, but spatial data, polygons. And you provide your OpenET API arguments defining like, well, what ET data do you actually want? And then pass in that information and say, give me the ET. And by the time that resumes, it's gone. It's fetched the field IDs for your polygons. It's attached them as attributes to your polygons so you can go do further lookups later. It caches those locally so it doesn't go ask for them again over the API. And then it goes and gets the ET in chunks to try to avoid as many requests to the API as possible, and attaches those as fields to your data frame as well, and then gives you the ability to export that back out for use in whatever other packages you want. Additional functionality. We started implementing some other methods via the raster API for time series at point locations, so we could do point sampling. As I mentioned, it caches your requests, partially for quota savings, partially because it's a beta product basically, and occasionally it'll crash, and you don't want to lose that quota usage you just made, and so it's that response is already saved. You could go retrieve it. You can also just send your own requests. So if there's stuff that's not included, you could still use the same connection information that you've already provided and send your own raw requests. And as this notes, this was our first method. We built this in 2021, but we needed a few more methods because of the volume of the data we had. We were regularly blowing through our quotas and still not able to get all the data we needed. And as I mentioned, it needs updates to the V2 API to work again. So I'm hoping I've intrigued some of you. Relevant details, where you can get started looking at it to see if it's even worth your time. The code's all in GitHub. Installation looks like that. Again, it won't work right now, but it's all set up for that. We have documentation set up. It's not fully fleshed out, but to show you, we were trying to make this a full open source, ready to go data product or package. We just didn't get all the way there. The license is the MIT license, which, if you're not familiar, basically says you can use it for anything you want, commercial or not. You just can't blame us if it goes wrong. So, but it's very permissive, so it'll integrate into anything you want. And we'd like to update the functionality of the V2 API, but I'd much prefer to do it as a community effort as opposed to me just making it work for us. So we're looking for contributors. That brings us to EDL, the Earth Engine downloader. So when we talk to OpenET about our data access needs, they're like, well, hey, it's all available on Earth Engine. And monthly data works great for a lot of our needs. We're often summing to annuals, as you heard from Emily. And we can run some of this in Earth Engine, which is great. But we also have a lot of post-processing people want to do, and having the ability to locally evaluate the rasters that are actually coming out when we were using it, not just getting some summary number from Earth Engine, but being able to do that visual QA on what's coming out is really helpful. So we needed a tool to get that data out of Earth Engine at large scale. And in the process, we decided it'd be really helpful just to have this generally for Earth Engine. So this isn't limited to OpenET, but we developed it specifically to pull OpenET data out. And one of the things, I'd be curious how many of you have run into this problem. You've had Earth Engine exports not work because you tried to export too much data. Anybody? Yeah, more than a few. So one of the things you need to do is you need to configure Earth Engine to slice up your data, which then means that once you download it, you need to reassemble it, which is fine if you're doing one or two. But when you're doing hundreds or thousands of exports, that's prohibitive, right? So EDL handles that. It configures Earth Engine to slice it up. It retrieves all the pieces. It reassembles them all separately for you. And your values for fields like the geodatabase API, they're all possible. But I personally feel like running zonal stats in Earth Engine is really clunky. So we actually do all that as post-processing locally. You're already getting the rasters, so we run raster stats locally to get polygon information. And that saves you from having to upload your polygons to Earth Engine as an asset too. So our Python package automates all of this. What it does, you provide the image or collection you want to export. As I mentioned, it could be a computed image. So you can take their OpenET monthlies and sum them to annuals in Earth Engine and then say, give me the annuals as an export. And what it does, and time range, area, all that stuff, you provide your image. It iterates through all the images you want. It slices them up into smaller pieces. Earth Engine does that, but it helps configure that. It exports them through cloud storage. It then downloads them from cloud storage. It tracks them in cloud storage, downloads them in pieces. It reassembles them, mosaics them, and it generates zonal statistics optionally. So you don't have to do that. You could do it if you just want the images and not zonal stats. And very few of these pieces are challenging or difficult or technically complicated these days. There's commodity stuff that does most of these, but it's clunky, and that presents barriers to me handing it off, or to basically somebody on the Secure Water Future team says, hey Nick, I need a lot of ET data. How do I do that? And the answer was well, I can pull that for you, but I'd really like it to be, you run this package and it's documented, it's easy to go, and then it's more of a self-service model. So in icons, I'm not sure if this makes it clearer or less clear, but I have a lot of text, so here we go. But you provide Earth Engine images, your areas of interest, your time range, but basically you're slicing up and getting an Earth Engine image, as I talked about. And there are basically two loops here. You loop through and initiate all your exports, which slices the images up and sends them through cloud storage. I say cloud storage, that's it supports both Google Cloud Storage buckets, but also just Google Drive exports as long as you have the client on your computer. And then, just like with OpenET client, when you're ready, you can do all kinds of stuff in between while Earth Engine's executing the exports, because after that first loop, Earth Engine's processing it. It's putting those images in cloud storage. So you could do whatever other computation you need. And then you just tell EDL, wait for my images and return control to my code once everything's on my machine, once we're ready to go. So it waits. Whenever it detects any images ready, it downloads all its pieces and it starts mosaicing that back together as one image while it waits for the rest of them to download. So ideally, our time to completion is basically a little bit after Earth Engine finishes exporting all of them. We don't wait for them all to export and then do the post-processing. That's happening simultaneously. So, more code. This looks like a lot, but that basically the whole top half of this, that's standard Earth Engine in Python. That's getting a single OpenET image here for an example. We're pulling the OpenET ensemble collection, we're filtering it to specific geometry and date. We're just taking the first image in there and then taking out the ensemble mean band. So then after that, it's just 3 lines. We're a simple initialization of a class in our package, EDL image, and then calling the export, which kicks off the export on Earth Engine servers. And then at the end, we say, wait for the images, give it an output location, tell it how long to wait between pulling, and tell it to just run a mosaic when it's done. So that's what it looks like. And as I noted here, zonal statistics is optional with a little more configuration, but not too much. And then if you have more, you just run a loop. So for the alfalfa study, I'll show you what we actually ran for that right here. But basically, this handles a lot of stuff in between. But this is exporting thousands and thousands of images at once. We had 180 areas of interest, and I don't even know how many fields within there, but we exported 36 monthly images for 182 areas of interest, so whatever that math works out to. So we built a helper class here, and this one, we want something in between here, between that manual image export and this, but this one says, okay, I have a bunch of areas of interest, I have a bunch of polygons for fields within those areas of interest, and I have a time range and Earth Engine images. Go get me all of the images for that time range in each area of interest, download them, and then post-process them to those agricultural fields. So there's a lot of configuration here, but it's really 2 lines of code. It doesn't look like it, but it's 2. We count funny in programming, right? We have this grouped collection extractor, which handles it all. We're configuring it. Not fully documented yet, but will be. and then we kick it off and call the extraction itself. Limitations. So as I said, we want something in between that like manual and then that like really complicated multiple area of interest. What I'd really like to have is you provide a filtered collection and maybe an area of interest, and it kicks out the images for you there. I think that'd be a nice sweet spot in between that would serve a lot of use cases, but you tell me. And everything currently goes through an entire Earth Engine export, large or small. There's a new-ish Earth Engine endpoint that allows you to stream data directly into a Python array. I'd like to support that because that'd be pretty handy for smaller jobs where you could expect near real-time performance instead of an export, and broadly fits with the mission of it. We don't support that, but I think it'd be nice. And it requires, the real hang-up spot is it requires some knowledge of configuring Google Drive or Google Cloud. We've documented this, but it's not straightforward the first time through. So like you really do need to read that part of the documentation or talk to me before getting started right now. But like, let's round off the corners together. And this one, in contrast to OpenET client, which is like on its way to deprecation if we don't collectively revive it, this is under active development. We've stood up a lot of infrastructure to make this a first-class package. We have continuous integration running, a bare unit test suite. Like, can't even say it's tested, but it's ready to go if we start writing the tests. It also does code quality checks. It does type checking. It does all the kinds of things that you want for good code. The documentation is a work in progress. I was writing some of it yesterday on the way here, but like it's there. It's ready. It's linked. Licenses, the same permissive license. And it is ready to use today. It works. So I'd love your feedback. I'd love your contributions. Love your thoughts on what's actually needed here. And again, this isn't just for OpenET, but for us it is. But I'm sure we'll use it for other things. And what's next? Like I said, we have the infrastructure for testing. We want to actually put the code through tests with contributions, and then we want more thorough documentation. So just a quick comparison before wrapping up. I wanted to outline like the use cases for each of these. So they're both under basically per usage models in terms of costs. Each one has some sort of free tier. You already know about the OpenET API. Earth Engine's typically free for research uses, but for people at other agencies or commercial uses, you pay per use for exports, but it's pretty nominal. Notably, OpenET client has access to the full OpenET data catalog. EDL, the lag with what OpenET is able to update on those monthly catalogs it's like 6 to 18 months. I think they're aiming for 6 months, but it hasn't fully hit that cadence. Last time I checked a few weeks ago, it was through the end of, I think, 2022. So like we're lagging a little, but for older data, like it's still wonderful. They both have access to all the models, which thank you OpenET, at full source resolution. OpenET client has the geodatabase API. You can get polygon level data with EDL, but you bring your own polygons and run your own zonal stats, but it does it for you. Notably in EDL, if you want additional variables like precipitation, you got to pick your own from Earth Engine's data catalog, but you can use the same tool to do it. And EDL doesn't have access to the overpass date data or the daily data, but I have been told overpass date data is coming at some point. And we've already been through the status. So just a few relevant points there. And yeah, so 2 separate packages. Please get in touch if you'd like to contribute. I'd love this to become a community effort. And thank you very much. And we're at 12:30, so if you have, we can stick around if you'd like, but otherwise you might just need to find me. And
we have swag.
Oh,
we
yeah,
have koozies and stickers and temporary tattoos and reports.
Yeah, and in your reports. Great presentation. Yeah, thanks. I told you I had a pitch for you. Yeah.